welcome back to my YouTube channel. Now this video I'm going to show you SPM Physics Form 5 Chapter 4 that you could learn about logic gates and the truth table you derive from the various kind of gates. You're going to learn 5 logic gates in Form 5. 5 logic gates in Form 5, so I'm going to show you in this video. Now, to start off with, one will maybe ask, you should have your reference book, of course. It's logic gates. What are logic gates? Okay, it's actually an electronic switches. Okay, it's actually electronic switches. Very similar to what you have learned. What we have learned in the past about diodes. Okay, just that now it's a more complex electronics. But before, prior to this logic gates, in your reference text, they have an introduction of types of IC. You have digital IC. You have digital IC, integrated circuit. It means. And another one is called the linear IC. Okay, you may want to read through it, the theory and a few examples. What are those? And then the advantages for having an IC that normally comes out in a structure question. Then only we'll go to the introduction of logic gates. Okay, so as I mentioned, logic gates, it's actually electronic switches. Okay, where you have one or more than one input. Let's say I name this as input A, input B, input. Your input could be either off or on. Now, in binary, that normally, the electronic switch operates in only binary system that you have learned from modern maths. Okay, binary system. So in A, it could be on or off. In B, it could be on or off. So the combination of the both, therefore this logic gate is going to determine this operation. It will perform operation inside, and then they will give you a single output. So you're going to learn there are actually 5 different operations, and this kind of operation operates at only binary inputs. Okay, so to start off with, first, based on the input, you will get a truth table. Okay, so what are the truth table? Truth table generally shows, you may use my video and then make your own notes, and then actually it helps you during your reading. Okay, it shows all the results. It shows results of every or all possible output. Okay, there's a mathematical formula to calculate it. In order to find out the possible output number, what you need to do, your output could be either on and off. The same goes with your input, on and off. So your possible output number, and it's actually equals to 2 on and off, on one condition, off another condition, therefore making 2 binary system to the power of n. where n is the number of input. Okay, say for example over here on the left you have 1 input, 2 input, so therefore 2 here you will have possible output 4 outputs. Okay, this is based on 2 is because this is binary, a binary system, yes or no. Okay, then what happened next would be, let's say you have input A, input B. I will set up the table. Okay, so one way would be you list down A and B. So it could be either like switching on a switch. You have 2 switches to control 2 different light bulbs. So what would be? The first one would be both close, close. The second one would be one close, another on. Third one would be one on, B off. Then the fourth possible one would be on and on. Okay, so these are the 4 possible input. And then over the right hand side, this is the output. In this case, we can't get the output because we doesn't know what are the operation. We're going to learn the 5 operations, maybe next page. But one way to create this table, instead of listing out 0011, another way would be 0011, 0101. So you list now vertically. So you write 0011, 0101 to create the number of input. Okay, so another way to represent it would be through the graph form. I think you have seen it from your objective book, from your reference book, or perhaps in the chapter by chapter exercise. Maybe you have t time, and then maybe this is actually the y-axis, or maybe I use a t number, maybe I separate it using a dotted line. Okay, so so if there's a yes, then therefore you have 1, 0, 1, 0. Okay, so this is 0, this is 1. There's no way that in between, there's no 0.5. It's either on or off, that's all. Okay, this is to actually represent one kind of input. So this is 1, 0, 1, 0. 1, 0, 1, 0. Okay, this is one input. So if you have 2, then you need to sketch another one. Normally this graph is sketched for you already in exam. All you need to do is to find out how it should be. Okay, since I draw 1, 0, 1, 0, so 1, 0, 1, 0, it will be 1, 1, 0, 0. Okay, and then the combination of these 2 input and you get an output. So this is just the beginning of it. And then from a reference or text, they will have these applications and contributions. You will need to go through it so that you're able to do an essay question. And this input is very much depends on the operation that I'm going to continue. Next page here, or the left perhaps. So the first one, the first logic gate or the first operation, maybe I'll use across these 2 pages. Logic gate. Then I think it's good that to know the expression, or they call it Boolean, B-O-O-L-E-A-N. You may want to Google for this word. What does it mean? Boolean algebra. Expression. Or it's simply a mathematical expression. Okay, Then third column, that would be symbol. You need to know all of this. Then next, that would be the truth table. I'm to use across it, so the truth table. So we are going to have A and B, and then the output X. Okay. So the first one, you need to know in SPM Physics, that it's called the first one is called OR gate. OR. OR. Okay. OR gate, Boolean expression, Boolean algebra expression, where your output X is actually output. Boolean OR is A plus B. This A corresponds to this A, B corresponds to this B. Okay, your source. A plus B is OR. Your symbol for OR gate is, you have two input. This end is actually a curve end. You have curve surface, curve out, and then you have line. This is your X. This is your A, and this is a B. This would be the symbol for OR gate. It depends on questions. Sometimes they don't get you. Sometimes they ask you to sketch this symbol, or you are asked to write the Boolean algebra expression or the algebra expression. Okay, sometimes they just leave a Boolean. Okay, then in order for you to work with OR gate, so let's work with the truth table. 0, 0, 1, 1. That's too small. Since I've made use of this whole page, I'll make it bigger. 0, 0, 1, 1, 0, 1, 0, 1. Okay? If you have these two input, we go through this logic gate, this operation called OR operation, or the OR gate. What happened? Off, off is actually off. There's no light at all, right? Off, on, on, off, on, and on. Or you may substitute this number into the algebra expression. 0, 0 is 0, 1, 0 is 1, 1, 0, 1, 0, 0. 1, 1 is 1, 1 is actually 1. You get light on. Okay. Then the next logic gate is called the AND gate. We call A and D. Okay. That would be AND gate is times A dot B. Dot means times. The symbol will look like this. 1, 2. Look like a D, right? D and N. Look like D. So this is A, this is B, this is output X. So if you were to put into a truth table, that would be 0, 0, 1, 1, 0, 1, 0, 1. I need to actually separate this. Okay, so that you can see it. So you have AND 0, 0, 0, 0, 1, 0, because it's times, right? 1, 0 is 0, 1, 1, then only is 1. Okay, so that's the second one. You may want to pause this video and go to your exercise book and look for those questions that ask for AND gate and OR gate. Okay, or else you may want to proceed. The third one is the NOT gate, N-O-T, NOT, N-O-T. Okay, so NOT gate output X is actually the inward of A. It's a bar A. Symbol will look like this. Input, triangle. Don't confuse this with Your diode is different. It's a triangle, and then you have a circle. Okay, so you have A here, input, so this is your X. Your X is always on the right hand side. So this is rather simple. Logic gate, in the event when you have 0 bar, therefore you have output 1. There's no B because there's only one input. Okay, okay. Alternatively, you can get a NOT gate easily by using an AND gate. How can you do it? You have one input, then they share the same put, and then you get a 0 at the front, called a NAND gate. Sorry, I think I made a mistake. It's not AND gate, it's a NAND gate. I think I'm not going to cover it here. I'm going to cover the fourth one first before we go to NAND gate. The fourth one, they call NAND gate. NAND gate, that will be output is equivalent to A and B, just like AND gate, A and D, you have an N in front, not N, so there's a not. Whenever there's a not, there's a bar. So how does it look like? That would be A, B, input, this is the N, not meaning is a 0 in the front. So if A, B, this is X. This is N, and the dot in front is not. So not N, and it's NAND gate. Truth table, 0, 0, 1, 1, 0, 1, 0, 1. Okay? If you substitute this into the Boolean algebra expression, 0, 0, 0, 0, are supposed to be 0, 0, 0, 0, you get 1 because of the not. 0, 1 are supposed to be 0, it turns out to be 1, 1. This is 1, 1 is 1, not of 1 becomes 0. The fifth one, they call it not or. Not or. Not or, that would be output is equal to or is plus. Not, then meaning you will have a bar cross. I can write again. Sorry for the background noise. A plus B bar. So the symbol would be the OR is plus, so it looks like a plus. I mean, this is OR, and then not, you have a 0 in the front. This is your X. This is A, this is your B. How does it work? It works like this. Again, that would be 0, 0, 1, 1, 0, 1, 0, 1. That covers all the possible output. So for all, 0, 0 is 0, 0 plus 0 is 0, but since it's all of 0, become 1. 0, 1 is supposed to be 1, not 0. 0, 1 become 0. Okay, so this is how it works. Okay, and these are the 5 operations that you should know. And just now I mentioned it's possible to get a NOT gate easily by using a NAND gate. How to do it? Do it like this. You share the same input over a NAND gate, and this is what you will get to have the same effect. Let's say we have 1, 0 and 0, 0, 0. Incoming 0, so you get 0 and 0. 0 and 0 is equal to 0. get 1. Okay, you may test it. Let's put in some signal into it. Say you have 0, 0, 1, 1 input. Output would be 0, 0, 0. You get 1. 1. If you have 1 in here, 1 in here, 1, 1 are supposed to be 1, becomes 0 and 0. It's totally inward of your input. If you have totally inward of input, therefore, it's a NOT gate. Okay? NAND gate can be really useful to substitute the AND gate and OR gate. Okay? One example, another example would be AND gate. I'll do it in the next page. Say, for example, if you have not AND input, output, and then I share it with another non-gate. Okay, so what would be the output? Okay, so this is, let's make this as an example for your exercise, A and B example. Now, it would be nice if you label the Boolean algebra over the output here. So what's the output here? This is output would be A plus B. This is N, so it's A dot B bar, right? Then here input and output here would be A dot B. Oh, they're NAND gate after all, so doesn't actually need to do that, but it will be nice that you make this a practice. Okay. Another thing you might want to do would be first to feed in the signal. Say here input will be 0, 0, 1, 1. 0, 1, 0, 1 input, then the output, you know that 0, 0, 0, 0, 0, 0, it become 1. 0, 0, 0. Then 1, right? 0, 1, 0, become 1. 1 times 0, 0, become 1. 1 times 1 is 1, inward becomes 0. So this is output from part 1. Then they share it. It would be nice if you extend it to here so that you can have 2. So 1 times 1 is 1. It becomes 0, 0, 0, 1. Okay? So this output is similar to I have an AND gate. This output. Okay? So this is example how you want to solve problem that relates to AND gate. So is it 1, 2, 3, 4. Okay. Output. I'm showing a previous page. For AND gate, it's actually 0, 0, 0, 1. So in order to get the same effect of an AND gate, all you need to do, you use 2 NAND gate arranged in this manner, you get the same effect. Okay, that's all from me. You may want to stop this video and go for at least 8 to 10 questions over this same topic by using the same method I've shown you earlier here. you're able to solve. Normally they'll ask you for the output. If it's the first time watching my video, kindly subscribe to my channel, and I appreciate the thumbs up. Stay tuned to my next video.